Welcome back. So today we're talking about Hopital's rule. This is a French name and I don't speak French, so it's very, very possible that I am not pronouncing it right. And for whatever reason, whenever I read this word, it always looks like the word hospital to me. But Hopital's rule is a way for us to differentiate complicated limits and evaluate, not differentiate, to evaluate complicated limits. And some of you might already know how to do this. So hopefully it comes pretty easily, but we're using the derivative to kind of evaluate a limit. So we're taking some information that we've already learned, now taking new information and applying it back to it. So I've written out the rule here. Assume that f of x and g of x are differentiable on an open interval containing a, and that f of c is equal to g of c, which is equal to 0. Also assume that g prime of x cannot equal 0, except possibly at c. Then, the limit as x approaches a of f of x over g of x is equal to the limit of those derivatives of f prime of x over g prime of x. Notice, this is not the quotient rule. This is just the derivative of the numerator over the derivative of the denominator. If the limit on the right exists or is infinite, this conclusion also holds if f of x and g of x are differentiable for x near but not equal to a, and the limit as f of x x approaches a is equal to plus or minus infinity, same with g of x, and it's also valid for one-sided limits. Okay, that was a lot of stuff to say, but basically you can just take the derivative in order to find the limit. Let's actually do it. So here, our first example, we have the limit as x approaches 5 of 2x squared minus 9x minus 5 over x minus 5. If we were doing this before, we would have had to complicated, like factor this and break things up and kind of solve it, because we can't just substitute in 5, we get 0 in our denominator. But now we can just take the derivative. So this is going to be equal to the limit as x approaches 5 of 4x minus 9 over 1. Now if I substitute in 5, I'm just going to get 4 times 5 is 20 minus 9, which just equals 11. That's it. That's our limit. It goes so much faster. All right, let's do number 2 here. The limit as x approaches negative 5 of the square root of 4 minus x minus 3 over x plus 5. So this is going to be equal to the limit as x approaches negative 5 of 1 over 2 radical 4 minus x. And why do I write it like that? It should be a negative 1 over 1, right? So if I put in a negative 5, I get negative 1 over 2 times the square root of 4 minus a negative 5 would be 4 plus 5, which is 9, right? So this is equal to negative 1 over 2 times 3, which equals a negative 1/6. Okay? Went pretty quickly, even with me thinking slowly. All right, so let's do a few more examples that kind of amp up the usage. Number 3 here, we have the limit as x approaches negative infinity of x squared over e to the x. Well, if we did this, we're going to have negative infinity squared as infinity over e to the negative infinity, some huge complicated number, right? And so let's actually calculate this. We're going to get the limit as x approaches negative infinity of 2x times or over negative e to the negative x. And even again, we're going to have infinity over infinity, still a huge thing. So let's use L'Hopital's again. You can do it again. Negative infinity. So now we're going to have 2 over e to the negative x. So this is going to be 2 over, looks like some huge number, which is just going to be 0. Okay? Let's do example 4 here. The limit of 2 complicated polynomials that, frankly, I don't want to deal with at the moment, I can just differentiate here. So I'm going to have 3x squared plus, this should be a minus right in between there, plus 2x minus 8 over 3x squared plus 16x plus 20. Okay, still pretty complicated, still a lot to deal with. So let's do it again. So now we have 6x plus 2 over 6x plus 16. And if I put in negative 2 here, I'm going to have what? Negative 12 plus 2 over negative 12 plus 16, which I'm running out of room here, but that's going to be negative 10 over 4. which is just negative 5/2. Okay. All right, let's do some with some trig and transcendental functions, because there's nothing more fun than trig. Teens love trig. All right, the limit as x approaches 0 of sine of x times 1 minus the cosine of x over x squared. Okay, well, big problems already. This I can break up, actually, and rewrite it as the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of 1 minus the cosine of x over x. Okay, that's already going to help us out quite a bit to just break it up like that. Now, I can take our derivative here. The derivative of sine is equal to cosine, so the limit as x approaches 0. We're going to have cosine of x times, limit here is going to be cosine, so negative, just sine of x, right? So the cosine of x is, the cosine of x. The cosine of 0 is equal to 1 times the sine of 0 is equal to 0, which equals 0. Okay? Let's do number 6. The limit as x approaches 1 of what's going to be 1 over x minus 1 over e to the x, right? So now we're going to have 1 over 1, so I guess this is just going to be 1 minus 1 over e, yeah, which is just going to equal to 0. Okay, that one wasn't too bad. All right, and let's do 2 examples with positive and negative, or just infinity, but you know, it still works for positive and negative infinity. All right, so if we put an infinity here, we've got a huge number here, and actually this one is not too bad because we've got x cubed over x cubed. You know, you could just cancel all this out and you're going to get 3/4, but I'm going to show you how this will work anyways. So the limit as x approaches infinity of 9x squared plus 10x minus 3 over 12x squared. That's going to be the limit as x approaches infinity of 18x plus 10 over 24x, which is equal to the limit as x approaches infinity of 18 over 24, which is just going to simplify down to 3/4. So worked out exactly the same. And final one, the limit as x approaches infinity. We're going to take the limit as x approaches infinity of 8x minus 3 over 2e to the 2x plus 1 over x, okay? Which is I'm going to take a derivative again. The limit as x approaches infinity of 8 over 4e to the 2x minus 1 over x squared, right? So if I put an infinity here, I'm just going to get 8 over some huge number, right? Some huge number, which is just going to equal 0. Okay, so that's it. That's L'Hopital's rule. Hopefully you can see how we've taken past information and present information, kind of fused it together. If you have any questions, leave them in the comments, and I will see you in class. Bye!